I'm Shinsuke Sato from NICT. I am a radar meteorologist, so I'm not familiar for data simulation. However, as you know, data quality control is very important for data simulation. So today I'd like to talk about the real-time quality control in the data in 30 seconds. Okay. At first, we developed the phase array with we call the EAWR power more than 6 years ago. First radar installed by Osaka University in 2012. Okay, so from now we have 6 power in Japan. I have no photo in Yuan, but however, all phase array radar is for research purpose, not operational. The last phase array radar, MP power, it has a dual polarization function. And I have a responsibility to operate the radar Osaka, Kobe, and Okinawa. So this data, radar data this is a radar antenna has already presented. So in square antenna, there are 128 slot antenna. And using this slot array antenna, we transmit the fan beam and receiving as a pencil beam using a data beam forming technique. So this electrical scan, less than 0.1 second, we can get the 100 elevation angle. So, and one rotation is in 30 seconds, so we can get the dense 3-dimensional data in only 30 seconds. Okay, so the 3 radar data we published in this web page. This is a real-time display, and you can retrieve the past data like this. So. This is a 3-dimensional nowcasting, has already mentioned. But this is one motivation for the real-time quality control. So this 3D nowcasting is developed by Otsuka-san about 2 years ago. So and now Riken site is publish this result. And also this result has used in a smartphone application. We call the 3D Amagumo watch. Amagumo means the rain cloud. So anyway, so 4 years ago, we developed this application. We collaborate with MTI Correct. This is a free application for Android and iPhone, so if you have interested, please install. However, only Japanese. Sorry. Anyway, so you can get the real-time such kind of 3-dimensional image, the phase array data. Okay, so this is our main talk today. So in the first stage of the Miyota-san big data simulation project, Juan Luis has developed the Kyushu algorithm for the BDA experiment. Yeah, his algorithm very good to remove the clutter, surface clutter echo or so on. However, one problem is calculation time is about 40 seconds. This is too long, so we need a more faster and general purpose quality control algorithm for the big data simulation and 3D nowcasting. So the request time of the real-time QC calculation and then the transfer is within 10 seconds. So we have to simple algorithm. We developed the simple algorithm. This is a sample of the actual data. So there are many not used or abnormal cluster. For example, this is a ground cluster, and this is maybe airplane. Sometimes this is interference echo. Sure. So we need to remove such kind of the abnormal cluster echoes. So I proposed the QC flag, 8-bit QC flag, includes eight kind of the QC. This QC flag provided in the same radar coordinate, radar grid points. So yes, and okay, and this includes valid data. Okay, and shadow means just from the data elevation map and the equivalence Earth radius. So and also we have information on the building near the radar site. So this is a shadow, and the second one is cluster possible is statistical cluster map using fine data, many data in fine day. Okay, and the certain cluster flag means using Doppler velocity or texture information. And interference noise is also detects such kind of the threshold. And rain attenuation, you know, so this is X-band radar, so strong echo, far from the strong echo, from the rain attenuation, the quality is no good. So we need to such a flag. So the final range side lobe is one of big problems. So later I'll explain this flag. Okay, this is a result of the PPI plane, elevation 2 degrees. So upper panel shows observed reflectivity, and the bottom panel shows the result of the quality control flag. And this is a stratiform case. So you can green means just a shadow. This is a building shadow. This is from the mountain. And yellow and orange shows surface cluster. Okay. This is a convective case. This is very contaminate the rain echo and the cluster echo. So yellow and blue is valid rainfall data from this shows. Okay. And this is interference noise. Okay, this is range side lobe contamination. So this is very strange feature for the phasor weather radar. This is a kind of a hardware problem. However, anyway, so very strong echo, far near the strong echo, we can get, you can see the such kind of false echo like this. So using a threshold, we detect the such as the purple. Purple shows the length size of echo. However, this is depend on the parameter or threshold. Maybe later, so James will present it. This is a very big problem. Okay. Okay. Next, this slide shows last year's record-breaking heavy rainfall. So this case is strong rainfall that continues more than 3 days in Kobe. This is radius is 60 kilometers. So such kind of strong rains are very continuous. So one of the characteristics of this case is a strong echo are embedded in widespread stratiform rain, like this. In vertical cross section, you can see the this is stratiform echo. You can maybe you know this is bright band. This is melting layer, snow from to rain. So, but this is a convective rain like this. So this is embedded such kind in the. So, and this is very difficult for the quality control. This is the original one. This is the result of the QC flag. So anyway, so such region, delete the data. However, this is incorrect because very strong echo in stratiform, or like this, a very strong melting layer level. So such kind of this is difficult to determine the correct QC. So it is current one of current problem. Okay, so finally, this is just a computation time. So yeah, anyway, so only one CPU, one core is more than 30 seconds, but using open MIP, so we can get less than 10 second calculation. Okay, in summary, so I introduced a phase array with data like this, and data quality control is essential for data assimilation and 3D nowcasting because observation data includes various unnecessary echoes. We have developed real-time data QC within 10 seconds. And last I showed correct QC flag were calculated in most of convective or stratiform echo, but incorrect QC flag were also seen in the case of the record-breaking heavy rainfall. Well, another case is I have some problem. Okay, so thank you for attention. So.